Hi, welcome to Illinois Groundwork. This is an online resource of tools and research to help with the design and planning of green stormwater infrastructure. And I'm very pleased to introduce you to Dr. David Grimley, Principal Research Scientist with the Illinois State Geological Survey. And Dave's going to talk about landform and soils across the state of Illinois. There's a fascinating geological history having to do with periods of glaciation that have shaped the landform across the state and region, and that as a result contain different types of deposited soils that were carried through by glaciers and also that were further manipulated through glacial melting. And so the kind of variability and complexity across the landscape is a really interesting story, but it tells us a lot about how humans have used and occupied the lands and waters across this region. And today, that complexity and variability is really important as we consider different ways that green stormwater infrastructure can be planned and designed into those different contexts, those different kind of soil contexts that are tied to that geological glaciated past. So here's Dave.
Thank you, Mary Pat. Now I'm going to talk today about glacial deposits and landforms in Illinois and how they affect native soil variability. So, to give a little background, glaciers have been in North America several times during the Pleistocene in the last couple million years. And this map shows the Laurentide ice sheet and how it grew to its maximum extent over that time. And it happens that the southernmost extent of continental glaciers in the northern hemisphere, the limit is in Illinois, south of Carbondale, probably due to topographic reasons. And if you zoom into the Midwest a little bit further, you can see that here. That was during the second to last glaciation during the Illinoisan, about 150,000 years ago, when ice was at southern Illinois. Now, earlier than that, there was a pre-Illinois glaciation that came in from the west, from Iowa. And there's the last glaciation, which reached Des Moines and reached central Illinois, but not to the southernmost part of the state. So this shows you the extent of all three major glaciations, although there were a few more than that. So again, here are sort of the last three major glaciations shown on this map, and how the last two came from Lake Michigan and the earlier one came from Iowa, and how they've overlapped along the Illinois River Valley. We're going to zoom in a little further on the next page, but this figure on the right shows a cross-section showing you the subsurface and how deposits, particularly in central Illinois in the Bloomington area, where you have all three last glaciation, the Illinoisan and the pre-Illinoisan, laying on top of each other, a few hundred feet thick, and there are thick deposits of sand and gravel there, which make up the aquifer, the Mahomet Aquifer, that serves as drinking water for much of central Illinois. So these have important societal significance. And the variability in the materials is of importance to what I'm talking about today, and we'll get more into that in detail as we go on. So for the last glaciation, there are several moraines in the northeast part of the state, which can be dated with fossil leaves and wood and other material. And those radiocarbon ages are between 17,000 and 28,000, depending where you are in the state, getting younger towards Chicago as the ice receded. These are a couple of photos of the moraines. And this diagram is a conceptual diagram showing the great variability of materials that you have in the glacial environment, including meltwater streams in front of the ice, proglacial lakes that are trapped between moraines and the ice front, lakes sort of in undrained depressions and ice blocks, water draining into the glacier and along the bottom. All of this causes a real complexity of materials. Once you melt the glacier and the sediments are left behind, we have glacial till, we have outwash, which is the sand and gravel in front of the ice sheet. You have lake deposits, you have alluvial sediment, You have sand and gravel below the ice, and you have thick glacial till, maybe multiple layers of that from a fluctuating glacial front. So there's all that complexity there that we see today in Illinois. This is how we know about those environments, is studying modern glaciers. And so, for example, this is outwash material in front of a glacier in northern Canada, where you have sand and gravel here in the meltwater sandbars. And these are proglacial lakes in front of an ice sheet here in Alaska. The lakes are often trapped between highlands or moraines and the glacial front, but also in sort of areas where you've had ice blocks and depressions. And this is glacial till depositing below an actual glacier, where there's sediments, pebbly sand, silt, and clay all mixed together and compressed by the weight of the ice. So there are a number of different types of landforms that we have that are related to glaciers and even post-glacial streams since glaciation. And so many of the landforms we still see today are reflecting the glacial times, and some are from more recent, but we still have a very strong imprint from glaciation. And because of that, we have a strong record of deposits from glaciation. And so that's what we're showing here on the right. And for each landform, there's a typical deposit. So I'm going to show you a few here. We have lake deposits in a lot of these blue areas, which are lake sediments. They're often stratified from different seasonal deposits or different years. And there are sand dunes that are no longer active. This particular one is being mined for sand. And these were common during the high velocity winds of the glacial times and less vegetation. And likewise, we had wind-blown silt, which became lush deposits. And those are thick in southwestern Illinois and cover much of the state with at least a thin deposit. And finally, we have till, which is one of the most common glacial sediments across the state. It's not always right at the surface, but it's found under much of the area of Illinois. And there are other deposits, but these are 4 examples. Now, to make things a little more complicated further, we have soils developed into these glacial sediments. And so here we have a typical soil in central Illinois with a topsoil A horizon and a B horizon subsoil developed into loess material. And below that would be glacial till. And you have effects of the parent material, you have effects of the drainage, you have effects of vegetation on the soil types. And so you have that complexity superimposed on the complexity of the parent materials themselves. And this block diagram kind of shows you that as you go from this soil to that soil to that soil, you have different parent materials for the surface soil profile. And that geological substrate in turn affects some of the practical things that we've been doing for projects in southern Cook County, where we've been studying the infiltration rate of water flow through the soils and glacial sediments. So this kind of brings us back to some other videos where we looked at the mousometer and saturated hydraulic conductivity, and sandy sediments where we have dune sand or beach sands are affecting the hydraulic conductivity compared with more impermeable lake sediments that are fine-grained here. And then up here we have glacial till material and near-surface bedrock and other sediments that would have different characteristics as well. So that's kind of pulling this together, how the glacial sediment variability and the soil types may affect the native soil conditions for societal use. You could look at some of the other videos that we produced on the mousometers or the saturated hydraulic conductivity or other ones related to this project. Thanks a lot.